Alright, so now we're going to actually talk about the new thing with equations this year, which is our exponential equations. Exponential equations means that our variable is going to be in an exponent. So it's not going to be like a normal equation. Our exponent is going to have a variable in it. Okay? So there are some general steps to solving. I'll get to those in a second, but before I do, let's just look at an example of an equation here. So let's say I had, well, let's just do a really basic example first, not even equation. So let's say I have 2 to the second power equals 2 to the second power, right? That's a true statement, right? Because 2 to the second power is 4 equal to 4, right? So that would be true. Now, what if I did this? What if I did 2 to the x power is equal to 2 to the second power? Could I figure out what that x is? Yeah. Right? All I'd have to do is think, okay, the only difference between these two equations is the exponent. If this has the same base and they're equal to each other, that means their exponents have to be the same too, right? So if these are equal, that means that x has to equal 2. So just looking at it, I can see x is going to equal 2. I've solved for x already. Okay? That's generally what we're trying to do with these exponential equations, is we're trying to get these exponential equations so they have the same base. And once they're at that point, if they have the same base, that means their exponents have to be equal to each other. So then we just kind of ignore the bases and focus on the exponents. Okay? And if you look right here on this worksheet, it actually lists the steps. The first thing you do is isolate the base. Write both sides of the equations, exponential expressions with like bases, okay, and then set the exponents equal to each other, solve for the unknown. So basically what it's saying is it wants you to figure out which base you're trying to get everything to. So in this example, it wanted them to get to a base of 2, okay. Then it wants to write both equations as exponential expressions with like bases. So it wants me to get 32 to a base of 2. So to do that, you got to figure out how many times 2 goes into 32. And the way I usually do that is I'll write it up here in this margin here. And usually I'll have like the other side of the equation over here as well. And I'll do that when I actually get to these examples. But basically what I do is I'll divide until I get to the base I'm trying to get to. So I'll divide it until I get to 2. Okay? When I divide 32 by 2, it initially will give me 16, right? So I'm not at 2 yet, so I'm going to divide it by 2 again. Okay, 16 divided by 2 is 8, so still not there. So I'm going to divide it by 2 again. That's going to be 4, so still not there. So I divide it by 2 yet again, and that gives me 2. Now at this point, it's really easy to see how many times 2 goes into it. I just have to count up how many 2's I see. I've got 1, 2, 3, 4, 5. So if I were to take 2 and multiply it by itself 5 times, I'm going to get 32. So I could rewrite 32 as 2 to the 5th power, which is what they do right here, 2 to the 5th power. Okay, then once they have the same base, they're going to drop the bases, set the exponents equal to each other, and just solve for x then. So it was 2 to the x minus 3 is equal to 2 to the 5th. Those exponents must be equal to each other, so you can drop them. You would add 3 to the other side. That means that x is going to equal 8. Okay? Let's look at an example of this being done. So let's look over here at number 1 here. Now generally, you know what base you're trying to get to because one of the sides is already going to be in that base. So for example, number 1, it's already at a base of 5. So I want to get 125 to a base of 5 as well. So when I divide 125 by 5, I'm going to get 25. So still not there, right? So I divided by 5 again. That gives me 5. So then I can rewrite my equation. So it's 5 to the x is equal to 1, 2, 3. So I can rewrite 125 as 5 to the 3rd, 5 to the 3rd power. Now I have the same base. I can drop the bases, set the exponents equal to each other. X is going to equal 3. Easy cheesy, right? Let's look at another example. Let's come down here. Let's look at this one. This one's a little tricky, right? So I've got a fraction on this side. Before I do anything with that fraction, though, I'm going to try to get this 16 down to the base I want it to be. So I want it to be a base of 2. So I'm going to divide 16 by 2 until I get to 2. So divided by 2 will give me 8. Divided by 2 gives me 4. Divided by 2 gives me 2. So I've got 1, 2, 3, 4 2's. So I could rewrite this equation as 2 to the v is equal to 1 over 2 to the 4th power. Now, if you guys remember the exponential properties, I talked about the negative exponent situation, right? Negative exponents were just fractions, right? If we wanted them to be happy, we would move them downstairs. Well, what if we wanted them to be unhappy? If we wanted to make him grumpy, what could we do to make him grumpy? And we could move him upstairs, right? If we move him upstairs, we would have to make this exponent negative again. Which, that sucks for him to be negative, but that would make it so we have the same base, right? They would both be a base of 2 again, just with a negative exponent. So if we do that, that's going to give me 2 to the v power is equal to 2 to the negative 4th power. Hey, look, I have the same base now. I can drop the base, set the exponents equal to each other. V is going to equal negative 4. And that's it. I'm done. Okay? Not too tough. Let's look at another example here. Let's look at number 8. So this one actually has a bit of an equation to do. But first I need to get both sides to the same base here. So looking at it right now, looks like I needed to get it to a base of 5. So I'm going to divide 25 by 5, and I get 5. So what can I rewrite 25 as? Looks like 5 to the 1, 2 power. So I can rewrite that equation as 5 to the 2r plus 4 is equal to 5 to the 2nd power. Now do I have the same base? Yes. So I can drop the base, set the exponents equal to each other. Gives me 2r plus 4 is equal to 2. And then I just got to solve for r here, right? So two-step equation, best friend acquaintance. Acquaintance would leave first. Gives me 2r is equal to negative 2. Divided by 2. R is going to equal negative 1. And that's my answer. Again, not too tough, right? Once you know how to rewrite these as a certain base, it gets pretty easy. Now number 10 gets a little trickier. It's throwing a curveball for you. Because is this base all by itself on one side? No. It's got this 1 over here first, right? We need to get rid of that 1 before we can actually know what base we're looking at. So we need to get this base all by itself first. So I would subtract the 1 first. So minus 1 would give me 3b to the plus 1 power is equal to 81. Now I can kind of see what base I'm trying to get to, right? Trying to get to a base of 3. So I'm going to divide 81 by 3 to see how many times 3 goes into 81. So divide 81 by 3, you get 27. Not quite there, right? So divide it by 3 again, gets you 9. Still not there. Divide by 3 again, gets me 3. So 3 is going to go into 81 1, 2, 3, 4 times. So I can rewrite 81 as 3 to the 4th power. So that's going to give me 3 to the b plus 1 is equal to 3 to the 4th power. Now I've got the same base. I can drop the base, set the exponents equal to each other. b plus 1 is equal to 4. And then I've just got to solve. So I got an acquaintance I need to get rid of, so subtract them. B is going to equal 3. And that's my final answer. And that's pretty much all you got to worry about with the exponential equations.